It's by Fatemeh Akrami, who will be talking about network differences that we observe in patients with bipolar disorder. Fatemeh, it's your turn.
Okay, thank you. In this study, we want to investigate about bipolar disorder and its alteration on topology and synchronizability of functional brain network. It's shown that bipolar disorder impact on cognitive functions such as speech, behavior, and decision making. And we know that some deficit in brain regions associated with bipolar disorder and functional brain network impairment is related to disorder as well. On the other hand, graph theory provides an opportunity for us to identify the connectivity between multiple brain regions, and we use it to know about the bipolar impact on brain. Previous study showed that in this study, they used magnetic resonance imaging, and they found that in BD, among BD participants, we have longer characteristic path lengths, but clustering coefficient decrease as well as global efficiency relative. On the other study, they use EEG and graph theory analysis show that synchronization in alpha band and clustering coefficient as well as global efficiency decrease, but clustering path lengths increase among BD individuals. We know that bipolar disorder changes brain waves activity and powers. For example, there are increase in theta activity, and synchronization is decreased in alpha band, and in the resting state eye closed condition. So there was a question for us that what happened in the brain in BD condition in the resting state eye open. We focus on the brain synchronizability in theta wavelengths in eye open condition, and we know that theta wavelengths is more related to memory, navigation, and brain-wide network processing. We have 21 BD and 21 healthy participants. We use EEG for data collecting, and for pre-processing, we use EEG lab, and we use Loretta for localization, and ultimately graph theory for analysis. Our results show that there are significant difference in theta band in clustering coefficient. You can see that among BD participants, we have increase in clustering coefficient and increase in global efficiency, but decrease in the smallest, second smallest eigenvalue. As mentioned before, in this study, we use graph theoretical analysis to investigate topological among BD patients. We use EEG as well, and we found out in theta band, clustering coefficient increase. It means that segregation and local processing increase among these patients, and global efficiency increase as well, which more related to integration and transferring data. But second smallest eigenvalue decrease, which show that robustness and resistance in network decrease. So our findings support the hypothesis that in theta band, the functional topological of brain network in eye open condition is affected by BD. In conclusion, we can say that BD as a disorder changes brain synchronizability and alters topology, and in theta band, brain wave activity change, so data transferring and data processing influence on this disorder. Thank you.
Thanks for the wonderful talk, Fatemeh. As we are waiting for people to type in their questions, I had a quick question about how you build these graphs. So what type of measure did you use to calculate the connectivity?
We use lag coherence.
Oh, lag coherence, phase lag coherence. Okay, got it. Did you see any other any differences in other frequency bands like alpha band, because that's the most strongest band when you have an resting
Not
state, right? Not significant.
In eye open condition, no.
Okay, got it. So yeah, there is one more question from Conrad Coding. how do you interpret global efficiency?
Global efficiency is more related to, as I said, it's related to integration. This means that the integration in brain network increase, and it's more related to transferring the data. It means that the data transferring in theta band increase in BD condition.
So there is an increase in data transfer.
Yes.
Okay. That's so like, how do you interpret then what BD is actually, right? So we have these, I mean, these are people who have both like the manic and depressive episodes. Do you think this increased transfer is present throughout, or is it in only like certain phases of their disorder?
Sorry, I don't understand your question. Please repeat it again.
Sure. So in bipolar disorder,
So,
BD so in these patients, they exhibit a different symptoms at different time points, right? So at some points they are manic, and sometimes they are depressive.
yes.
So do you think this global efficiency is increased throughout the entire period, or did you have any information on what phase of the disorder they were in when you collected the data?
Yeah, there are some differences between the people who suffer from bipolar disorder and depression in theta band.
Okay.
We select these people, and then we found that yes, in among the people who have different theta band, the transferring data increase.
Okay, got it. Okay, so as we are looking for questions, if the other panelists have any questions, please feel
Yes.
free to unmute yourself and ask.
I think I have some more technical question about the graph theory. Are you thresholding the graph in any way, or are you taking the raw graph as it is? Because there's so many like thresholding methods to simplify the graph or binarizing it.
No.
You're taking the raw graph. Okay.
Yes.
And the second question is about the smallest eigenvalue. What is the motivation behind this? I'm not familiar with the details of this graph theory analysis, but how do you come from the eigenvalue to the robustness of the network?
Let me ask my co-author to answer this question. Sorry.
Oh, he's there. Great.
Hi.
Hello.
Hello. So the second smallest eigenvalue is from the spectral graph theory, and a spectral graph theory technically talk about the dynamic of the graph. And first we need to calculate all of the eigenvalues and eigenvectors of the adjacency matrix, and after that we can see the spectrum of the eigenvalues. And especially the second smallest eigenvalue is related to the dynamic of the graph, the robustness of the dynamic of the graph. So when we have higher second smallest eigenvalue, we can say the graph is more is in a more robustness condition, and when we have lower value, then the robustness is decreased. And we saw that in the patients, the robustness has been decreased. Yeah.
Thank you. That's really comprehensive answer.
Sorry.
I know it's a really technical question. I'm super interested in this. Thank you.
Yeah.
All right. So if we don't have any more questions, I think we can probably wrap up the session. And I'd like to thank the panelists again for these wonderful talks, and also the attendees for being here. And just a quick reminder, please feel free to share.